Hey there, welcome back, maybe. That's if you watched the first video on the unit circle, which you may or may not have needed to do. That video just went over how I view the unit circle, but if you have it memorized and your way is fine for you, then that's all you need. However, when you look at this video, what I'm going to do is I'm going to go over 10 problems that really you should be able to do quite easily if you have the unit circle memorized. And it's just to let you know to what level you would be expected to know the unit circle as you go through calculus. So if you want to, you can fast forward through the video to find certain ones of these that you might feel a little uncomfortable with. Notice that these last two might seem a little foreign to you, so that you might want to fast forward to that. Also notice that I've taken a unit circle and haphazardly drawn one with the values in the first quadrant, because if you have the values of the first quadrant memorized, you really have the entire unit circle memorized. You just have to be careful of the pluses and the minuses. So without further ado, I'm just going to start peeling through all of these, and you watch the ones that you think you need. Okay, we'll start off with sine of pi over 6. I'm going to do these on separate sheets of paper. Sine of pi over 6. And so simply I would say there's the location. Cosine is a travel to the right. Sine is a travel upward. That's a long trip, short trip. Sine of pi over 6 is 1/2. Couldn't get easier than that. All right, so then the next one, cosecant of pi over 6. All right, so the unit circle is based off of sine and cosine values. So as soon as you're outside of sine and cosine, you're going to have to do some sort of arithmetic fractional gymnastics with sine and cosine. Cosecant of pi over 6 is really 1 over sine of pi over 6. And since I already have the sine of pi over 6, which is 1/2, this is 1 over 1/2, which is 2. Third one, cotangent of 4 pi over 3. All right, I'm going to take a look at where is 4 pi over 3 on the unit circle. So if I go up here, this is 1 pi over 3, 2 pi over 3, 3 pi over 3. 4 pi over 3 is going to be this location down here. And cotangent is the reciprocal of tangent, or 1 over tangent. And tangent is sine over cosine. So here's what I'm going to do. I'm going to rewrite this to say cosine of that location divided by sine of that location. By the way, tangent is sine over cosine, so cotangent is cosine over sine. Now I think about that location. To get to that location, my cosine is a trip in the negative direction, and it's the short trip. The sine of that location is the downward trip, so it's in the negative direction, and it's the long trip. I refer to short trip and long trip based on that first video if you watched it, and I have a negative square root of 3 over 2. So now, believe it or not, on the AP test, on an extended response, you can leave your answer in that form. You don't have to simplify, but let's say you have to match a multiple choice answer. What I would do is multiply by the reciprocal, multiply by that reciprocal, and I get a positive 1 over square root of 3. And I know you were told that was naughty to have a radical in the denominator, but it really isn't naughty. You're allowed to do that. And some people might have the twitching urge to take 1 over the square root of 3 and rationalize that's also a totally valid answer. So go with that if you want. All right, I'm trying to pour through these. Secant of pi over 3. I'm doing the fourth one. So if I were going to do the secant of pi over 3, secant is 1 over cosine. and the location pi over 3 has a cosine value of 1/2. So I'm getting another 2 there. But now let's look at this one, secant of 7 pi over 3. All right, 7 pi over 3 doesn't seem to be a famous unit circle stopping point. But remember, if I did an entire trip around the unit circle, I would land back there and I'd be at 2 pi, or that's 6 pi over 3. So if I went another pi over 3, I would be there. So this location pi over 3 that we used in number 4 is the same location for number 5, so that's also going to be a 2. Go up here to number 6, secant of negative 5 pi over 3. This negative means we're traveling in the negative direction around the unit circle. So I'm going to head this way. And I'm going to stop just short of negative 2 pi, meaning a pi over 3, or a third of a pi short of going all the way around, which means, once again, I'm going to end up at that spot. If you want to look at that another way, negative pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3. So problems 4, 5, and 6 are 3 different ways of asking the exact same question. Tangent of pi over 2 for number 7. Now, some of you have memorized the tangent function, and you might know this answer right away. I call you weird, but that's all right. You do what you got to do. I don't have the tangent function memorized, but I do know that tangent is sine over cosine. And so now I take a look at the pi over 2 location right there. I get a 1 for the sine value, but the cosine value is 0 at that location. Divide by 0, you know what happens in the math world when you divide by 0. Big explosion. We get an undefined. So you could use that symbol, or you could say undefined. But let's look at number 8, tangent of pi. All right, so if I'm looking at the location pi, it's right over here, and we would know that those coordinates are negative 1 comma 0. And now we have a 0 over a negative 1, which is a 0. That's not an undefined. We've done nothing naughty here like we did up here. So we're going to get a 0 for an answer, which now leaves us these last 2 problems. And these may be rusty in your brain. This is inverse trigonometric functions. So I'm going to take a quick break to show you why you would care about these, and then we'll do number 9 and 10. So this equation is going to be an example of why you would care about these last 2 unit circle problems, where we use inverse sine, or otherwise known as arc sine. We'll talk about that in a little bit later. But if I were to solve this equation, I'm going to try to solve for x. So I would move the 4 over to the other side. Then I would divide by the square root of 2 on both sides. And now you want to get x by itself, which means you need to get rid of the sine, which means you apply the inverse sine, because in algebra, inverse operations fight to the death. So I would apply the inverse sine. And if I do it to the left side, I do it to the right side. Now the advantage of applying the inverse sine there is this. The inverse sine and the sine function fight to the death, and the x escapes. So that means if I can turn this into a number, I have my answer for x. And to turn that into a number, I just have to know how to do the unit circle thinking in reverse. Quick side note, I'm using the notation inverse sine, but please remember that, let's see, where can I write it up here? Inverse sine of x is the same thing as, it's interchangeable with arc sine of x. Just two different math symbolisms to say the same thing. All right, so maybe we'll come back and figure out what the answer for x is here after we do these next two problems. So now if I'm asked, what is the arc sine of 1/2? Here's the what I have to ask myself. I say, okay, where on this unit circle does sine have a value of 1/2? Well, I see it right there at pi over 6, and unfortunately, it's also going to happen at 5 pi over 6, which can confuse people. Well, my answer is going to be pi over 6 and not 5 pi over 6, but here's why. For sine, inverse sine, we're only going to select from this region of the unit circle. And that way we won't have any doubled up answers. When we get to number 10 and we're doing inverse cosine or arc cosine, we're only going to select from this region of the unit circle. That's the eligible domain. So the answer here is pi over 6, which basically means this. If I would have asked you, hey, what's the sine of pi over 6? You would say, well, that's 1/2. That's the unit circle thinking you're used to. This is just in reverse. This is saying, if the sine was going to be 1/2, what's the location on the unit circle? Let's take a look at this one. We're using the inverse cosine notation instead of arc sine. And so what this is saying is, where on the unit circle will my cosine value be 1/2? If I go up here, I see it's right there, but it would also be right here, which is 5 pi over 3. But since the cosine, inverse cosine, only uses this as the domain or the eligible answers, my answer is going to be pi over 3. So you really aren't using any new knowledge when you do these inverse trig functions. You just have to think about it a little bit more carefully because you're doing it in reverse. So if I go back to this problem we were doing before, it's asking for the x value that would make that equation work. So I need to know, where is my sine value equaling that? All right, well, it would be right there. And so that would be the location negative pi over 4. And you got it. Okay. Hopefully there's not much new here or nothing new at all, but I just wanted to make you aware of kind of to what degree you would be expected to know these unit circle facts, and they'll be with you all year in calculus. See you later.